All right, so section 2.3 talks about functions. So we have the definition of a function here, and it says relations and functions right there. A relation is any set of ordered pairs, and a function is a relation in which for each distinct value of the first component of the ordered pairs, there is exactly one value for the second component. So let me kind of explain what this means here. The first component of the ordered pairs usually refers to the x value, and the second component is going to be our y value. So what that means is that for each distinct x value, there is exactly one y value. Okay, so it says for every relation consisting of ordered pairs x and y, there are two important sets of elements. The set of all the values of the independent variable x is the domain, and the set of all the values of the dependent variable y is going to be the range. So we got a couple of problems here where we're trying to figure out if each relation is also a function. So actually, you know what? Before I do these two here, I'm going to scroll down and I'm going to look at this one. Okay. So I like to use this problem as my first example simply because it's visual. We can kind of see what's going on. So guys, this here is going to be my domain, and this one here is going to be my range. Okay. And the definition of function says everybody in the domain can only be with one person in the range. So think about, remember, these are relations, right? And think about, if these are relations, think about relationships. Okay? Everybody here, in order for it to be a function, everybody here has to be faithful. Okay? So let's see. 2 is going to 1. 2 is not cheating. 5 is going to 1. 5 is not cheating, right? Okay, so these people here are not cheating. They're hooking up with 1, but they're not cheating. As far as 2 knows, it's the only partner for 1, right? Same thing with 5. 11 is going to 7, not cheating. 17 is going to 20, not cheating. 13 is going to 20, not cheating, right? So you might say, well, look, these guys are. I'm not concerned about these guys. In order for it to be a function, the ones that have to be faithful are the domain. So here we would say this is a function because everybody here is being faithful. So when I scroll back up to these problems and it says determinant of each relation is also a function. Look, I'm going to draw the same kind of picture that I had before. So I'm going to say here's my domain, here's my range. Remember what the domain is. The domain are the x values. So I'm going to come back over here and I'm going to look at my x values. 1, I'm not going to write it again. 0 and 2, and then my range are my y values. So remember, these are my y values. So I have 1, -1, 0, 4, and -4. Okay, so I'm going to look at the first point. 1 hooks up with 1. 1 hooks up with -1. 0 goes to 0. 2 goes to 4, 2 goes to -4. Remember what we said, in order for it to be a function, these people here have to be faithful. And you liar, you told me I was the only one. These are the ones that are cheating. So this here would not be a function, right? It's not a function because those two numbers were paired up with more than 1. So you might say, okay, I get the visual, right? It's kind of easy to see when you look at the picture. If I didn't want to have to draw the picture, how could I tell whether this thing would be a function or not? And the way you would tell, the x values are the same, but the y values are different. Or the x values are the same, but the y values are different, right? Okay, I like drawing the pictures just because I think it's easier to see, so I'm going to do that. But again, you don't have to. I just think it works best. So again, I'm going to put my x values here. So 2, 3, 5. I'm going to write down my y values over here. 5, 7, 9, 11. And I'm going to draw my arrows. 2 goes to 5, 3 goes to 7, 3 goes to 9, 5 goes to 11. Not a function, right? Not a function because of number 3. Okay. All right. Again, one thing I want to point out, guys, when I come back and I look at this problem, the first one we did earlier, notice how each of these people here do not cheat, right? I'm not so concerned about these people cheating. It's these people that have to be faithful, all right? So let's scroll down again. Okay, and again, I can look at this as, look, 0 goes to 0, -1 goes to 1, -2 goes to 2. This here is, again, a function, right? Okay, so let me just make sure that we did everything we need to do. Okay, I had a feeling I was forgetting something. All right, so the one thing I was forgetting was this part right here. Find the domain and the range. So the domain here would be the numbers, what was it? I'm going to put them in order, 0, 1, and 2. And the range would be the numbers, if I put them in order, I guess you don't have to put them in order, I'll just list them. 1, -1, 0, 4, and -4. Okay. Again, same thing here. My domain would be my numbers 2, 3, and 5. And my range would be the numbers 5, 7, 9, 11. Okay. Let's see. My domain for this one would be the numbers 2, 5, 11, 17, and 3. And my range would be the numbers 1, 7, and 20. Okay. My domain here are the numbers 0, -1, -2. And my range are the numbers 0, +1, +2. Okay, that's not a 3, that's a little squiggly. I don't know what you think, sir. Why'd you put a 3? I didn't. Okay. All right. Now, there's something else here called the vertical line test. So, guys, vertical lines look like this, going up and down. Vertical line test says if a vertical line hits a graph more than once, then it's not a function. Okay, it's not a function. So let's see, let's draw a vertical line. How many times do I hit the graph? Once. How many times do I hit the graph? Once. No matter how many times I do this, my graph is only going to hit once. Now let's find our domain. Okay, remember what we said. The domain is a set of the x values, right? So remember, think about this. I mean, this really is a number line. So remember when we were doing our inequalities and I said like that's infinity and that's a negative infinity? Okay, so when I'm looking for the domain and I have a picture, the idea is no matter where I would be on my x-axis, whether I was over here or whether I was over here, somewhere in the middle, do you agree with me that if I were to go up, at some point I would hit this line because this line is going like that forever and ever and ever, right? So no matter where I would be here, or even down here, I would hit this line because that line really goes forever. So since I can do that for any number on this x-axis, my domain would be from negative infinity to infinity. Any number that I pick along here, okay? Now, let's talk about the range, okay? So I'm going to clean up some of this mess here, and I don't want to erase the blue so much. Okay, so now let's talk about the range. The range means my y values. This here, guys, is also a number line. And my negative infinity would be here, and my positive infinity would be up there, okay? Now, what the range says is no matter where you would be on this red line, if you were to pick a point here, you could move to the right, or if you could pick a point here, you could move to the left, and no matter where you would be on this red line, you could either move to the right or you could move to the left or even stay right there, and you would hit your blue line, right? And so then my range which is my y values, would be also from negative infinity to infinity, because no matter where I am on this red line, I could move to the left or I could move to the right, and I would always hit my graph. Okay. So now let's take a look at the next one. First thing we're going to do, determine is it a function. I draw a vertical line. How many times do I hit it? I hit it twice. Okay. So it's not a function. Okay. That's what the vertical line test says. Okay. Now let's see if we can find our domain. Remember what our domain is. The domain is a set of the x values. Okay. So if I start thinking about my x-axis, right? Remember, this is my negative infinity and my positive infinity, right? If I start off over here and I go up, I'm not hitting my graph, right? I don't hit the graph until we start at what number? 3. And then from every point past 3, if I go up, I'll hit that graph. Again, remember, guys, this thing is going to keep going like that and like that and like that forever, right? So on my x-axis, where do we start at? We start at 3, and we go all the way to where? To infinity. So just like we did our inequalities before, I'm going to go from 3 with a bracket to infinity. Okay. Now, let's take a look at our range. So I'm going to clean up some of this mess here, right? And let me go back and do a little bit of this and a little bit of that, right? Remember we said the range is. The range is the y values, right? So I'm thinking about this line right here. Again, this is my negative infinity, and that's my positive infinity, right? Okay, so what the range says is that no matter what point I pick, whether it's here or up here or somewhere in the middle, in this case, I would be moving to the right. And the question we want to know is, if I were to move to the right, at some point would I hit my graph? Now, I want you to look at this graph. Isn't it moving up? It's moving up, right? So this red line here at some point would hit it. And this part here is moving in a downward trajectory, right? So at some point here, it would hit it. And no matter how far up or how far down I went, I would hit that graph, because that graph, that's the basic shape of my graph, right? So then my range, if I'm starting down here and I'm going all the way up to the top, would be from negative infinity to positive infinity, okay? All right. And people often ask me, how do you know that that graph is going to go on and on and on forever? And the reason that I know is those arrows. Those arrows tell me that graph goes on and on and on forever, okay? Just in case you're wondering. All righty. So let's do the next one, okay? First thing, is it a function? Let's draw a vertical line. How many times did I hit it? Once. How many times did I hit it? Once. How many times did I hit it? Once. So do we have a function? Yes, we do. Okay. Now, let's talk about our domain. Remember the domain of the x values, right? So this is going to be infinity. This is going to be negative infinity. And all the domain is saying is that no matter what point you pick on this green line, whether you were to go down or whether you were to go up or maybe even stay right there, would you hit that graph? And if you're wondering, remember, look at the shape of the graph. I'm extending that line because I got those little arrows, right, that tell me it does this forever and ever and ever. So if I were to be here, I'd hit the graph. Even if I were to go further out, I'd hit it. Over here, I'd hit it. And obviously, every point in the middle. So again, my domain is going to be from negative infinity to positive infinity. Now, I'm going to lose some of this greenness because I want to see if I can do my range. Okay. So remember what our range is, right? The range are the y values, right? So remember down here is negative infinity and up here is positive infinity, right? Okay. And all it's asking me is if I were to go to the left, 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 or to the right. And sometimes like here, boom, boom, both, right? But I always hit my graph. And yeah, because that graph keeps going up and that graph keeps going down. So my range would be from negative infinity to positive infinity. Okay? So one thing I want to mention, sometimes the way it asks you to write it, the domain, if you remember, the domain refers to the x values, right? And when it's something like this, it might just say x is any real number, because it can be anything from negative infinity to positive infinity. And the range, remember, are the y values, and y is any real number, okay? So just giving you a heads up, they might be written that way, okay? Let me scroll down, and let's see if we can figure out some of these problems here. So let me do this a little bit. There we go. Perfect. Okay. So we got two functions here. The first function, f of x is equal to negative 3x plus 4. First thing we want to do is we want to find f of 0. So what I'm going to do here, guys, I'm going to do a little stare and compare. F of x is negative 3x plus 4. If you notice, the only thing that's different from here to here is now we're using a 0 where the x used to be. So I'm going to write negative 3 times 0 plus 4. So f of 0, negative 3 times 0 is 0, plus 4 is equal to 4. So that just told me that f of 0 is 4. Now, before I go on, I want you to think about these as points. Remember how points look? Points look like this, x and y, right? So the number that we plugged in for x was 0. The answer that we came up with would be my y. So if I were to think about this as a point, it would be 0, 4. Okay? Now, let's do the same thing for this one. It's f of 1/3. So I'm going to think of that negative 3, and I'm going to put a 1/3 right here, plus 4. I'm going to think of this negative 3 as negative 3 over 1. And the reason I want to do that is, remember how I multiply fractions straight across? Negative 3 over 3 plus 4. So negative 3 divided by negative 3 is a negative 1, plus 4 is a positive 3. Okay? So that just tells me that f of 1/3 is equal to positive 3. And if I were to think about this as a point, it would be 1/3, 3. Now, I want to mention something. The directions are only asking me to find those values. That's what I'm doing. But throughout chapter 2, we're going to talk about graphing functions. And I would just want you to understand that this is, in essence, what it is we're doing, okay? All righty. So the next one, it says f of p. So again, all I'm going to do is I'm going to come back to this function here, and everywhere I have the letter x, I'm going to write the letter p. And so f of p is equal to negative 3p plus 4. Okay. Let's do that again. And now we're going to plug in a negative x. So I have a negative 3 times a negative x plus 4. Remember, a negative times a negative is a positive. So I got a 3x plus 4, right? And is there another one? Yeah, there's another one here, f of x plus 2. Okay, so let me just write my original function again. F of x equals negative 3x plus 4, just so that I know that was my problem. Now we're going to find f of x plus 2. So I'm going to put negative 3. Instead of me writing x, I'm going to write x plus 2 plus 4. And I'm going to distribute that negative 3. So negative 3x, negative 3 times 2, negative 6 plus 4. And that gives me negative 3x minus 2. Okay? So f of x plus 2 equals this whole piece right here, right? So before I go on, let me kind of scooch back here. You know how we wrote these as points? Let me show you how you'd write this one as a point. P, negative 3p plus 4. And this one would be negative x and 3x plus 4. And this one here would be x plus 2 and negative 3x minus 2. Okay? I would do it exactly the same way we did those over there. All right. So, for the next problem here, it says, for each function, find f of 2 and f of negative 1. So, f of 2. F of 2 means I'm going to look at this function here, and I'm going to look for the part when x is equal to 2. Well, here it is. X is equal to 2. What is the y value? The y value is 2. Okay? And I'm going to do it again for f of negative 1. So I'm going to come back to this function right here, and I'm going to look for when is the x negative 1 right here. What is the y value there? It's 3. Okay. Let's do the same thing for our picture here. F of 2. 2 gets hooked up with 15, and negative 1. Negative 1 hooks up with 10. Okay. And we can do the same thing here, f of 2, f of negative 1, based on our picture. Okay. So, let me come over here. Remember what this means. I'm going to go to when x is equal to 2, right there. If I go up, what is the y value that we have? We got 3, right? And f of negative 1. So here's negative 1, right? If I want to hit my graph, I'm going to go down right here. So look, that's negative 1, negative 2. It looks like this one here is negative 3. Okay? All right. And let's do the same thing, jelly beans, right here. So f of negative 2. F of negative 2 means I'm going to go to my x-axis, and I'm going to look for the y value. Well, when x is negative 2, the y value is 0, right? That's part A. Let's do part B, f of 0. So I'm going to go to when x is equal to 0. If I go up, my y value is 4. Okay. C says, let's find f of 1. Go here, I'm going to go up. My y value is 2. And D is in dog, we're going to find f of 4. So I'm going to come back over here, I'm going to go up. My y value is also 4. And that was section 2.3. Pretty sure, yep, that's all of 2.3.